First of all, let me thank Dr. Harish Karnatak, head a course director for this Space Educators Training and Knowledge Upgradation Program. And it's a very good initiative. This being the 5th program, and also a very good initiative wherein the teachers are getting to know about the high-tech areas of space technologies and across the states and union territories. And I'm sure that will benefit a large number of students who form the total educational background of our country. So I will just, my topic will be on the Indian space program, future challenges and opportunities. So I'll touch upon our Indian, how it has grown, Indian space program, and also the new challenges which we are new developments which are going to come through. And basically they are also challenges for us, and also they give us the opportunity to showcase our scientific temperament. So I'll just give a brief overview of the Department of Space. So I think most of you will be aware, but still, for the sake of to have showcase the overall how the ISRO functions, or the Department of Space functions. So basically, it comes under the Prime Minister, Department of Space, and we have a number of units, centers, and units which actually focus on the R&D activities on launch vehicle, satellite application, space, planetary exploration, human space flight, etc. So on the left side, you can see the centers and the small units, and also we have autonomous bodies which are which form the R&D establishment and academic institutes. Then we have a new body called InSpace, which promotes, handholds, and authorizes private space activities. And also we have the to commercialize our technologies and that we have developed for the launch vehicle and satellite production. We have the ENSIL and Antrix bodies, and our activities are spread across India. So you can just, the map shows that. And these are the people, the visionary leaders who have led this organization, and starting with Vikram A. Sarabhai, and the past chairmans and the current chairman, Dr. V. Narayan, just to. And now coming to the activities of the Indian space program, they are actually organized in under 5 verticals. So as you can see, one is to access to space, basically, that is called space transportation. That is, we have to reach space. So for that, from Earth to space, you require launch vehicles. That is the one sector, one vertical. Then once you reach space, you require the satellites to carry out the activities in the space infrastructure, it is called. You have communication, navigation, different type of satellites will be there. Then we have, once the satellite is in the orbit, the data, it's transmitted down to Earth, and we carry out space application. The useful part of it, basically, that is called. There is a third vertical, and then we have the human space flight, which is the Gaganyaan program. We are planning to launch Indian to the space and bring him back safely. So that itself is the 4th vertical. And also the capacity building, the 5th vertical, which talks about our infrastructure build-up, outreach, human resources, technology transfer, international cooperation, etc. All this gambit comes under that. So basically 5 verticals are there. So basically all our program, the program of space program in India started in 1962 in a small village, fishing village near Thiruvananthapuram, that is located in Kerala, basically. And it was called Tumba Equatorial Rocket Launching Station. And from there, we had the Nike first sounding rocket, 21st November 1963. It's a Nike Apache rocket, small rocket, which is from US, and the payload was from France. So we had an international cooperation at that time itself. And then our rocket, that is the Indian-made rocket, our Rohini 75, the first Indian rocket, was launched from Tumba in 1967. And if you take the history, around 15th August 1969, ISRO was formed. And in 1972 June, DOS was, Department of Space was formed. And in 72 September, ISRO was brought under the ambit of Department of Space. And the sounding rockets, basically, there's a small rockets, and they are used for atmospheric measurements and performing scientific experiments during for the experimental purposes. And we are having number of sounding rocket. Different versions are there: RS-200, RS-300, RS-300 Mark II, 560 Mark III. So, and they are meant for a specific areas like middle atmosphere, ionosphere. So it's very specific to the experiments what we are planning. Then we had initially the launch vehicle. From the sounding rocket, we moved on to the launch vehicle. So we had the first launch vehicle was SLV-3, and the first launch was from Sriharikota on 18 July 1980, which put India as in the elite club of spacefaring nation. And this project was headed by project director was none other than Dr. APJ Abdul Kalam. And it was an all-solid motor rocket. And then we had the ASLV, where in the new technology, that is the strap-on technology, the core was same, and you had the side two more strap-ons were added. So it becomes a 5-stage vehicle derived from SLV, and the first launch was in 1992. And so the payload, if you can see the payload, it was SLV had only 35 kg payload, and in a 300 by 900 kilometer orbit. And the ASLV you take, it is 115 kg payload in similar orbit. Now, subsequently, we transformed ourselves to a major player in the thing, and we had the PSLV launch vehicle in 1993. Then we transformed from there to GSLV 2001 and launched LVM-3 Mark III vehicle. That is the biggest vehicle we have currently, and SSLV. There is a small satellite launch vehicle, and this shows how the payload has grown from 35 kg. We are talking about in PSLV, we are talking about something like 1,700 kg for the polar orbit, and in GSLV, we are talking about 2,200 kg for geotransfer orbit, and in LVM-3 around 4.4 tons into GTO orbit. The corresponding low Earth orbit payloads are given. We can launch up to 10 tons to low Earth orbit. SSLV anyway is a 500 kg payload in the low Earth orbit. It's meant for that. And we are under development. We are looking at the new generation launch vehicle, wherein we are going to go from whatever we had around 10 tons to low Earth orbit. In LVM-3, we'll be touching almost like 30 tons to low Earth orbit. So that is the jump we are going to take with the next generation launch vehicle. And now coming from launch vehicle, now we come to the spacecrafts. So we can see the spacecrafts. There are different types of spacecrafts, and each spacecraft has its own specific utilization. So we started off with the Aryabhatta, our first satellite launched in 19th April 1975. And subsequently, we had Earth observation satellites, communication satellites, navigation satellites, science exploration, technology development. So different varieties of satellites for specific purposes. And also the science exploration, we had the number of missions like Chandrayaan, Mars orbiter missions, AstroSat, etc., Aditya L1. And also technology development, we carry out some of the missions which will satellite missions which will feed basically into future satellite missions. Now coming to the space application, we are talking about in 1975. During 1975, we had a collaboration with NASA, and one of the largest sociological experiment in the world was carried out, which was called SITE, Satellite Instruction TV Experiment. And it was broadcast across the using ATS-6 satellites, and more than number of villages, more than 2,000 villages were connected, and program was transmitted. And basically, the application part, if you take the telecommunication, teleeducation, telemedicine, broadband, internet, etc. are there as part of communication. Earth observation, we all know agriculture, forest mapping, water resources, oceanography, different. And also space science, astronomy, planetary exploration. The navigation is that it has benefits which directly benefits a lot of including the marine, transportation, aviation, agriculture, etc. So here are some of the direct application areas like Earth observation. Take we can map the entire India for the drought vulnerability studies, for decentralized planning, um, forecasting, weather forecasting. So these are some of the areas which we carry out, and I think some of the things will be presented in or would have been presented by earlier speakers also. So land use, land cover map, national hydrology projects, supporting governance, paddy, subtle burning, area progression, so many are there. Now coming to the other is what you call forecasting the acreage, production of crops, the potential fishing zone forecasting. And here if you take up to 4 times increase in catch, because we are able to identify where the fishes are likely to be there, so the fisherman directly goes there. So he's able to his catch increases, and also the search for that he need not search. So with minimum search itself he is able to get around. So towards that there will be fuel saving itself that can come to nearly 5,000 crore per year. And the surface water assessment and monitoring. Then we have the natural resource assessment, cyclone disaster management. So if you take very specifically drastic reduction in lives lost by event, if you take we are able to, because of this evacuation effort, reduction in the evacuation, and 60% reduction in cost also has come, because we are able to identify the exact location where this cyclone will hit. So in that context, we don't have to evacuate a lot of people. We are required wherever the thing is going to happen. So in similar way, geoportals, governance application, more than 40 states and central ministries are part of this, as through mobile applications are there. So now, if you take the gambit of all the activities, it is, if you say almost like 101 launch vehicle missions are taken place, and also we have around 4,000 plus sounding rockets have been launched. Then satellite area, around 132 satellites have been launched, and that includes the remote sensing, communication, navigation, space science spacecraft. Also, we have launched 433 satellites of 34 countries. That shows our with respect to interfacing with the other countries. And 5 experimental missions have been, major missions are there, and application I have already gone through that. So this summarizes basically the total activities. Now coming to the launch vehicle, each launch vehicle are very specific. PSL, if we take, we had a special mission where we had 104 satellites in a mission. We launched in a single mission. That was a world record at that point of time. And it can launch multiple type of satellites like navigation, IIRS, Student Sat, Chandrayaan-1 mission has gone, Mars Orbiter mission, SpaceX, OM. So different type of things. And its capabilities are given here. I am not going to go into details. And now coming to GSLE Mark II vehicle, this is a vehicle derived from PSLE basically, but however, it has a special stage which is called cryogenic stage. The topmost stage, the stage you are seeing, CUS stage, there is there's a cryogenic upper stage which uses liquid hydrogen, liquid oxygen as a propellant combination, and this particular propellant combination gives the best performance among all the propulsion systems, liquid propulsion system. So that was used. That is mainly required to enhance the payload capability. We had only like less than 1,000 kg, and it was almost doubled to 2.2 tons to GTO using the GSLE Mark II vehicle. So we have 17 missions. And you can see the development of cryogenic upper stage being a very cryogenic technology itself is a very complex technology, mainly because the propellants we store at very low temperature, liquid hydrogen at minus 253 degrees centigrade and liquid oxygen at minus 183 degrees centigrade. At this temperature, most of the materials will become brittle. So we had to have special materials to store these liquids, transfer the liquid to the engine, and the engine what we uses turbo pump which runs at speed of 40,000 RPM, and at the combustion area, the temperatures can go to 3,500 degrees centigrade, and so no material can withstand that high temperature. So you have to use liquid hydrogen as coolant for the protecting the combustion chamber itself. So all this requires a lot of new technology which was to be developed, and finally we successfully realized the cryogenic engine, the stage. It was hot tested in Indian test stand. The special test stand basically, and finally in January 2014 we had the first successful mission, and here again initially 1993 we had basically it was supposed to be a technology acquisition, but however there was a technology denial, and then we went ahead and developed it. Subsequently we did indigenously developed this particular technology. And now coming to Mark III vehicle. Mark III vehicle is much simpler vehicle, but however, it's a totally different vehicle from the GSLE Mark II. Here we have the two solid motors, two S200. You can see the one legend. There are two solid motor strap-ons, and the center we have the L110 stage liquid with 110 ton loading stage. That is Mark II, and the third is another cryogenic stage. It's much bigger than the earlier, whatever I mentioned, the cryogenic upper stage. So it had a total lift-off mass itself of 640 tons and the GTO payload capability of 4.4 tons. And for the first time, we had a stage which was having a 4-meter diameter, whereas the earlier vehicles were of 2.8-meter diameter class stages. And here we had now all the missions, it's 100% success, and we had a major missions like Chandrayaan 2, Chandrayaan 3. We also had missions to OneWeb and OneWeb 1 and India 1 and OneWeb India 2, wherein almost like 36 satellites were launched at a single go. Now here, cryogenic, again, this particular cryogenic engine and stage which is used in Mark III is totally indigenous development, and it was a major accomplishment by India to develop this total indigenous cryogenic stage. And here, for the first time, we had the 20-ton thrust engine was developed. You can see the number of subsystem, number of tests which was carried out, and also we had the stage which was realized and tested on the ground, and also the flight which was done the 5th June 2017. We had the first maiden flight, successful flight, and in this process we also achieved some world records which I'll come in detail in the subsequent slides. So now this is the launch vehicle segment, and in the other satellite segment we had some in addition to the communication, whatever I discussed regarding the communication, navigation, Earth observatory satellites, we also have a very special segment called the scientific missions, where we had the Chandrayaan 1 Mars orbiter mission, Chandrayaan 2. So these are all to learn more about our moon, Mars, etc. And Chandrayaan 2, we had a very good launch. We we reached the moon. However, we had what do you call the last minute in the landing phase. We had a hard landing, and there was a national committee which gave a lot of recommendation. And based on this, basically, even though it was a failure, it is always a stepping stone for success. So based on this, we went ahead with the Chandrayaan 3 mission, and it was launched on 14 July 2023, and we successfully soft landed on the moon on 23rd August 2023, and you can see the landing profile. It was a major success. I think all of us were very proud of this particular mission. And we had number of scientific payloads and findings in the Chandrayaan 3 mission after landing. And also we did some experiments subsequently after the last phase of it, wherein we did a hop test, where we in the the lander itself, the engine was fired and just it lifted off, and just to demonstrate that we can, for the future, when I'm coming to the subsequent slide, we are talking about a sample return mission wherein we are supposed to come back to Earth, to return to Earth. So some technologies which possibly we can get some experience, that was demonstrated. Also the propulsion module was returned to Earth, entered into Earth orbit on 22nd November 2023. Then we have a major scientific mission, that Aditya L1 mission, and this was this made India one among the 4 countries to have a solar observatory on Lagrangian point, which is almost like 1.5 million kilometers away from Earth. So this was a major success, and already the spacecraft is in the orbit, halo orbit, and it is giving data. Continuous data is there, and also there are a number of payloads. I'm not going into details. Now, when we accomplished all these missions, in that process, we could achieve some of the world records. I'm very proud that India is holding some of the world records, like we discovered the water molecule on lunar surface, subsurface, and exposed by Chandrayaan-1 in 2008. The signature of OH molecules was found out. And also, if you take the Mars orbiter mission, this is the first Mars orbiter captured by Mars orbiter in the maiden attempt. This was the first time any country could do like that. First maiden attempt itself, we were successful. Then PSLV, as I mentioned earlier also, we had a single launch with 104 spacecrafts. And that was at that point of time, that was the world record. And till then, previous record was only 37. Then if you take the 4th, you take the highest resolution. Now Chandrayaan-2, even though it was could not land softly, there was one orbiter is there which is still working, and it is in the lunar orbit and captures high resolution lunar images, 0.32 meter against 0.5 meter from NASA. So it has the best resolution camera in a lunar orbit. So that's another world record for India. And if you take our Chandrayaan-3 landing on the southern polar region of the moon, that was the first time any country did that. So that's another world record. And also we did a lot of in situ in that particular area. We did a lot of in situ study of lunar surface elements, composition, temperature, and thermal conductivity. So a lot of measurements were done. So that also becomes the first time anybody has done it. Then coming to the cryogenic development in the country, as I mentioned, the C-25 stage development, engine and stage development, we had 3 major records: development and qualification of the first flight achieved with only 3 engines. Other countries were 4 to 11 engines they have used. And another thing was from the first engine hot test to the launch. We took only 28 months, whereas the other countries were taken around 37 to 108 months. And the third one was that the stage, if you take the stage hot test, normally it's a very complex process, and it is tested in a special test stand, and it stores, when you do a stage test, in the stage around 28 tons of propellants are stored. So it's a very hazardous also, because in case of a fire, something happens, some anomaly happens, the whole test stand can be lost. So in that context, we took only 34 days to complete the stage hot test. And other countries have taken nearly 68 days to 10 months in that process. And the current chairman, Dr. V. Narayan sir, was the project director and the development chief at that point, our C-25 development. So these are some of the things which we have. We are the world leaders, we can say, world record holders. And also Aditya L1, we are the 4th country to achieve that. SpaceX also, we have a special wherein we had proven the docking of the spacecrafts in the orbit, small 2 spacecrafts. So that again is the 4th country. Then cryogenic also, propulsion, basic propulsion is a very guarded technology. So we became the 6th country to have developed a cryogenic propulsion. And currently we are having 3 stages which we have developed in the cryogenic stage. Now, one is the world record holding. Then we are very proud that we are playing global leadership role in the space. We have the South Asia satellite. ISRO developed and launched the South Asia satellite in 2017 to share the benefit of space technology with South Asian nations. Bhutan, Maldives, they are utilizing this thing. We have a Indian Bhutan sat, where ISRO handheld the Bhutan for joint development of 20 kg satellite, which was launched in PSLV. And Chandrayaan-5 LoopX mission, which is getting ready now. ISRO is collaborating with JAXA, Japan, for lunar polar exploration. And the NISR mission is also getting ready for launch. We have ISRO and NASA is jointly realized the satellite, and we'll be launching using our launch vehicle, GSLV. And G20 satellite, under India's leadership, the G20 satellite is configured with opportunity for G20 nations for space-based observation for environment and climate change. So we also play a role in the global arena. And the commercial missions also, we have launched, as I told you, the OneWeb constellation of missions. 72 satellites in 2 missions have been launched, and the Proba 3 satellite for ESA, European Space Agency, was launched. Then we are going to launch the Bluebird Block 2 satellites in the coming this year itself, and 14 dedicated commercial launch service mission till date. And as I mentioned earlier, also 433 foreign satellites have been launched by India for 34 countries. Now, this is the background world leadership, and current in the recent past, we had some major successes. We can like SpaceX mission, where we docked 2 SDX-1 and SDX-2, 2 independent spacecraft, and they were docked in the space and docked. Then they were undocked. There was undocking also was there, and also we had the power transmission. When they are docked together, power was transmitted from one spacecraft to the other. So basically, all this technology are being developed for our future missions for Gaganyaan, Bharati Antariksh Station, etc. And also recently in January, we had the 100th launch to lift off from Sriharikota, which was a very successful launch of GSLV F-15. Now, these are some of the launches which happened, and also we are also developing the LOX, that is a semi-cryogenic stage, basically, which uses liquid oxygen and kerosene as a propellant. And basically, it will replace the GSLV Mark III. The core stage was L110 liquid propulsion stage. This stage will be replaced by this semi-cryogenic stage. And also the upper stage also will go for a enhanced stage, C32 stage. Now, using these 2 improvements, we will be able to increase the payload capability of LVM-3 from 4 ton to 5 tons. Basically, more than 1 ton increase in the payload to GTO is possible. So this technology is under development. Then we have one of the flagship program is the Gaganyaan program, where we demonstrate human spaceflight capability to low Earth orbit and ensure safe return of crew to Earth. And you can see around 400 kilometer orbit it will go. And basically, the technologies required towards this is a man-rated vehicle, a launch vehicle, then crew module and service module systems. Crew module which will house the astronaut, Gaganyaan-3 we call them. They'll be there, and service module which will help go from where it is the launch vehicle, where it drops to the orbit, 400 kilometer orbit. So all these technologies, and also once the mission is over, the crew module re-enters Earth, and it has to be safely using the parachute. It will come down and finally splash to the sea, and we'll have to go and recover it. And basically, this technology is a massive totally new technology, and a lot of activities are going on. And already the launch vehicle has been, all propulsion systems have been human rated, and crew module, service modules are getting ready, and we are going to have the the first uncrewed mission, that is without human, will go to the space, followed by a number of 2 more uncrewed missions, and then we'll have the crewed mission. So you can see the technologies which are to be developed: human rating of launch vehicle, integrated vehicle health management system, orbit module, crew escape system. Crew escape system is required in case of eventuality in this launch vehicle at the launch pad, or as it ascends. In case something happens, then we have to take the humans who are sitting in the crew module away from the launch vehicle. So towards that, a crew escape system also is developed and tested, and the environment control and life support system, that is what will provide the environment for the Gaganyatri. Basically, the person sitting there, human, he requires a certain amount of pressure, temperature, as well as oxygen requirements are there. So it will ensure that. Then the parachute-based deceleration system for the crew module as it enters Earth. The crew training, we have to train the crew, and also the different products which are required for safety of the crew, thermal protection, then protection of the crew, micrometeoroid and orbital debris protection system, basic mission management, and crew recovery operation using the ships. Now, towards this, the crew escape system, as I mentioned earlier, we already had a mission test vehicle for crew escape abort demonstration, and it was successfully accomplished. For this, a new vehicle was a single liquid stage was used to demonstrate the ascent phase, and at which point of time this crew escape system will come into effect, and the crew module was recovered using spacecraft which flashed down on the sea, and then ships went and recovered the crew module. So as I mentioned, we are going to have a number of missions, and we are going to have 3 uncrewed missions, G1, G2, G3 uncrewed missions, and then we'll have a crewed mission, followed by 1 more crewed mission, and then we are going ahead with the space docking, as well as the first Bharati Antarik station. That is, we are going to have our own space station in the orbit, and the first module of that will be launched as part of this Gaganyaan follow-on mission. And also, now I think everybody is waiting for the eagerly waiting. Tomorrow is going to be the launch of our Gaganyatri. Subhanshu Shukla, he'll be going on the SpaceX mission, launch vehicle to International Space Station, and he'll be conducting a number of experiments there. So we are also we wish him well, and all activities are progressing as planned. Now this is what we are doing, or we could we're carrying out. Now we are having our own India's Space Vision 2047. So in the Space Vision, it is a roadmap across by 2047 up to 2047, and this was declared by Prime Minister himself. And you can see the basic idea is how to reach moon. Basically, the final goal will be landing an Indian on the moon and then bringing him back safely. And towards that, it cannot be accomplished by a single mission. It has to be using multiple level of technologies are required for that. And towards that, if you will have a launch vehicle system where slowly we'll upgrade from GSLV to the next generation launch vehicles. We'll have our own Bharati Antarik station, and also Chandrayaan sort of missions, which will demonstrate the docking, our capsule return missions, etc. So all this together will handhold in India going to the moon. Now, as I mentioned, the Bharati Antarik station, if you take, it is a major program wherein there will be 5 modules which are docked in the space. You cannot carry this, almost 52-ton mass is the total. So you cannot carry, a single vehicle cannot carry it. So we'll have in multiple segments. So the first segment already is approved, and we are going to launch and then then the other balance 4 segments will be launched, and they will get docked, and you can see the configuration of the Bharati Antariksh station, and there will be number of technologies which will get developed during this process. Then we have our Chandrayaan-4 mission, wherein Chandrayaan-3 was a soft landing mission, and and we did in situ experiments. But in Chandrayaan-4, we are going one step ahead. We are going to land on Moon, then bring some samples. We'll collect the samples, store it safely, and then bring it back to Earth. But however, this particular mission cannot be accomplished using single launch. So we will have 2 launches. There will be ascender and descender module will be 1 launch. Then we will have the propulsion module, transfer module, and re-entry module together going in the second launch. So both will get docked, and then will go to Moon, and then landing, and then bringing back by the propulsion module and the transfer module and re-entry module. So you can see the mass. If you take Chandrayaan-3 was 3,900 kgs, whereas Chandrayaan-4 is almost like 9,600 kg. That's why you require 2 launches. Then we have another Chandrayaan-5 mission, which is basically the LUPEX mission. That is a ISRO, NASA, JAXA mission, collaborative mission. And this is much bigger lander and rover system. You can see the lander of Chandrayaan-5 will be like 6,150 kg, whereas Chandrayaan-3 was only 1,747 kg. And the rover which moved on the surface of the Moon was only 25 kg in our Chandrayaan-3, whereas here it will be around 350 kg. So that is the technology which will be, the rover will be developed by the JAXA team, whereas the lander will be developed by ISRO. And now one more new launch vehicle, that is the next generation launch vehicle, is getting ready, and you can see that it's going to use a new propulsion system, LOX methane propulsion system, and you can see the engine and the size of the rocket is going to be a massive rocket, nearly 91 meters tall. You can see with respect to the human what is the height of the system, and basically it will give us the capability of launching 30 tons to the orbit, low Earth orbit, and followed by the crewed lunar module launch vehicle, where we are going to launch move to Moon. That will be much bigger vehicle. It will be a modular vehicle which will be almost like 116 meters tall, and here we are going to go to the Moon. Now coming to Venus orbiter mission, there's another mission to plan Venus, and basically we will demonstrate the basic technology of interplanetary exploration and demonstrate Venus science. Instruments will be there, and the payloads include a collaborative contribution from Russia, Sweden, Germany, and we are targeting by 2028 this particular mission. Then our Mars landing mission. This is a future mission which we are planning, wherein we are going to land on the Martian surface and do experiments there. Then towards all this, we require the infrastructure. There are a number of infrastructure. However, there's going to be another launch pad which will come up at Sriharikota, which has to for meeting the next generation launch vehicle requirement. Now, these are some of the major things. Then in addition to that, ISRO always carries out number of technology demonstration activities. We develop the technology in parallel using technology demonstrators. And you can see we had the reusable launch vehicle, RLV technology, which was demonstrated without, that is, autonomous landing was demonstrated. And in the coming days, we are going to have a orbital re-entry experiment, whereas that particular RLV vehicle will go to the orbit, and then it will come back to Earth and land on an airstrip. Then we have the other new technology like air breathing propulsion system, which was already we had demonstrated in the dual fuel scramjet mode in 2024. and bigger scale version will be future development flight. We are planning for a longer duration and to have a sustained um, acceleration using a kerosene fueled scramjet engine. So this is another project which is going on, and a number of other technologies, semi-cryo engine, in situ resource utilization, some synergetic air-breathing rocket engine, rotating detonation. These are a number of things which are being studied by younger generations. Now coming to our the capacity building area, we are having the research opportunities in ISRO programs. Number of methods are there. We have the space technology incubation centers. Around 6 numbers are there. We can get projects done through them, and the regional academic center for space. Again, there are 6 numbers, and the space technology cells, center of excellence, sponsored research programs are there, and we have a very good interfacing with academia. And recently we have the space technology incubation center facility was inaugurated, um, which was basically NIT Rourkela, and it will serve the 5 states: Odisha, West Bengal, Jharkhand, Bihar. This is very specific, but across the India, all 6 regions are being covered. Okay, on the left side, you can see the number of institutes where we have tie-ups. And also we have this National Space Day, which commemorates the landing on the date of landing on the moon, 23rd August. So last year, 2024, we had the Honorable President of India as a chief guest, and we had a number of programs across the countries, dividing the country to 7 zones, and we reached out to more than 2.3 lakh students. And in addition, we have number of students outreach programs like Bharatiya Antariksha Hackathon. We have a Yuvika program for the 9th standard students. Then we have the students near space on wheel bus, which goes for the exhibition areas also at different places. And the International Moon Village Association has declared that July 20th as the International Moon Day. And ISRO during this week does various outreach activities for the students. So there are a number of World Space Week also. October 4th to 10th also is celebrated across the country. We conduct a lot of exhibitions, programs at various places, and we try to reach out to maximum people during these programs and enthuse them in the space science and technology. Then we have the other part is the social impact of space reforms. You know that country, Prime Minister, the government has rolled out the space reforms in 2020, and the activities have sudden exponential growth has happened in this country. You can see in 2014 we had only 1 space startup in this country, and currently we are having more than 300 plus space startups in the country. And towards that, very clear directions are there with the government, and the US also is supporting all the activities, and the InSpace is the lead in that, which carries out this activity, and clear definition of roles are there. And you can see number of private space players have come through Skyroot. We can see the Agniban launch. We are having number of satellites being launched by private agencies itself. And in this process, ISRO also supports the startups through our facilities. We can provide them facilities for their testing. You can see the tests being carried out at the ISRO facility. Also, launch pads are provided, and the payloads, small payloads or demonstration things, technology demonstration, whatever the startup wants can be demonstrated on the PSLV platform. So all these are being carried out on a regular basis, and this is increasing. The exponential increase is there in this space sector arena in India. So I will conclude my presentation. Basically, in all these 3 areas: inspiring young minds, capacity building, and synergizing the nation resources, and also achieving our target as the Space Vision 2047. Towards that, there are a number of challenges to be met, and I'm sure all the ISRO, we are ready to take up all the challenges, and I'm sure the young generation of people whom you have direct contact with, they also will be enthused, and also they also will become part of this journey. And I'm sure India, we are, as a space technology organization, we should be able to take India forward for in our through our means to make it as a um, developed country, by when we as a developed country in this across the globe. So in that context, I think our contribution is as important as any other contribution across the sectors. Thank you.